Alright, let's begin with our first topic, that is mathematical tools. In the beginning, I must say one thing, that mathematics is always acting as a spine for physics, and without mathematics, we can't proceed in physics. Now, in this topic, we are going to discuss 3D geometry, the basics of 3D geometry, and the basics of vectors. And everything, whatever we are discussing in this topic, that will all be useful in the further lectures. Let's begin with 3D. So whenever we understand the 3D geometry, we always consider the left hand bottom corner of the room. And easily you can locate these three axes, that will be X, Y, and Z will be coming towards you. So you can just denote them. And now uh, we have named these three axes as east, north, and up. The y axis is generally upwards. Obviously, the opposite of these axes will be west, south, and downwards. Fine. Now, this is the basic 3D geometry which you always have to keep in the mind whenever we'll discuss the problems related with 3D in physics. Now, the first thing which is important and you might have discussed in the junior classes, that is the displacement vector. Now, what exactly is displacement? It's like a particle which is moving from one point to the another point in 3D. So the shortest path is known as the displacement vector, or the shortest path is known as the displacement. So let's take 2 points, like the first point will be P, this will be 3, 4, 7, and let's take this as -1, 2, and 4. So the displacement will always be like from initial to final, and we always have to subtract the final points minus the initial points. So it will be like -1, -3. This is the final point and this is the initial point. Fine. So this will be like -1, -3 in x-axis. Then we have 2 minus 4. This will be in y-axis. And in the z-axis we'll have 4 minus 7 in z-axis. So you can clearly see that vector has three different components in all the three axes. Okay. Now the major thing is, like, instead of writing so much like in x-axis, in y-axis, and in z-axis, we have given some denotion to these three axes. That will be x-axis is known as I cap, this is j cap, and the z is known as k cap. So the opposites will be like minus I, minus j, and this is minus k cap. Fine. So if we have to write our answer like the displacement vector, so how can we write this answer? So this will be like -1, -3. This will be -4 I cap because it's an x-axis. My 2 minus 4, that will be -2, and that is in y-axis. So this is given as j cap. We denote that y-axis as j cap. And in the z-axis it will be -3. This is k cap. So this is the very simple denotion of a vector. I cap, j cap, and k cap, like x-axis, y-axis, and z-axis. Alright, so now from here, why this is important? Because whenever we'll discuss physics, whenever we'll discuss the problems related with physics, we might discuss those problems in 2 dimensions. And discussing 2 dimensions and 3 dimension will always require direction. That is the basic of a vector, which we are going to discuss now. A vector is a quantity which is having magnitude as well as direction. Now the basic thing is, if I say let's proceed for 5 units and I don't tell you the direction, so that could be any direction. Like if I say if I say like go 5 units, so it could be like moving in any direction. But if I say we have to move 5 units in each direction, so that is specific now. So I have specified the direction, so that is the basic between vector and a simple quantity scalar. Alright, now let's begin further and discuss the vectors. So this was the basic denotion of a vector which I told you. And now let us take an example. Let's take an example side by side. So we can take this vector as a vector. This is the way we denote the vector, like a with an arrow over it. So this is 3 I cap plus 4 j cap minus 5 k cap. So let us consider this is a vector. Fine. And how we are going to take the magnitude of a vector? The magnitude will be the squaring of these values, 3, 4 and minus 5. So if we have to take the magnitude of a vector, so this will be under root of 3 square plus 4 square plus minus 5 whole square. So if you solve this further, this will be under root of 50, and we can leave it over here. We don't need the further calculation, like it will be 5 root 2. We don't need that. So this is the magnitude. Okay, this is the magnitude of a vector. So this is the way we have to proceed. And now there is one more thing which is like a unit vector. And what exactly is this unit vector? Unit vector is basically vector divided by its magnitude. Fine. So for the previous vector, whatever we have considered, this 3 I cap, 4 j cap minus 5 k cap, and its magnitude was coming out to be root 50. So how we define this? A unit vector of A, that will be 3 I cap plus 4 j cap minus 5 k cap divided by root 50. Alright, I must tell you one more thing. The physical significance of all these things will be coming later and later. Like it will be coming in the further lectures. But this is like the basic mathematical ideology which you have to follow while solving the problems and while understanding the basic derivations of physics also. So this is the unit vector. Alright, now how we are going to see a vector in 3D? Vector is just like an arrow in 3D. Okay. Vector is just like an arrow in 3D. Okay, I'll come to the statement later on. The magnitude of the unit vector is 1. I'll come to the statement later on because I have to explain this with an example. But let me first continue the topic in this direction cosines first. Now the first thing is, in the direction cosines, we are going to consider a vector which is just like a line in 3D. And we denote that line as a vector, which is making 3 different angles. Obviously, if you consider any line in 3D, that will make 3 different angles with x, y and z. So here, if we are just going to take the same example, this is like a vector is 3 I cap plus 4 j cap minus 5 k cap. This is the a vector. You had the magnitude of this vector as root 50. So it's very simple. Like the direction cosines will be the angles made by the 3 axes. So this part, I must tell you one thing. Let us consider this a vector as 3 I cap. I'll tell you one important point here. This 3, this is known as 3 parts. This is known as 4 parts. In y-axis, this is 5 parts in minus z-axis. So like in x-axis, it could be like 3 parts here. Y-axis could be 4 parts here. And in the minus z-axis, I have to make it like over here. Somewhat over here. Axis which is going opposite to this plus z. Fine. So let us consider this a vector here which is making these, which is having these 3 components in x, y and z. 3 parts in x, 4 parts in y and 5 parts in minus z axis. Alright. So we already consider this vector and this had its magnitude as root 50. Now, how to find the direction cosines? The direction cosines will be this x portion divided by the magnitude. So this will be 3 by root 50. The y portion, the angle with the y portion, y axis, that will be the y portion divided by root 50. This is 4 divided by root 50, and in the y axis the angle made will be minus 5. The angles could be negative. Not the angles could not be negative, but we have this value of cos is negative because cos lies from -1 to +1. This is the range in which the values of cosine vary. Fine. So these are the three angles made by the made with the three different axes in 3D by a single vector. So now this is the way we have to proceed further. All right. Now let's discuss one very important part of this vectors, that is the dot product. We'll come to this formula later on. Let us consider we have these two vectors, that is like x, y and z. So we'll directly start with the example here. So whenever we have these two vectors, like this is a vector and this is b vector. So how to find the dot product first? Like we have to find a dot b. So this is like the multiplication of the values in x, in y and in z axis. Like whatever values will be given to you, you have to multiply them and add them. So it will be 3 multiplied by 1 plus it would be 2 multiplied by 1, and then it will be minus 4 and minus 3. Alright, if you solve this, you will get 3 plus 2 plus 12. So this will be 17. So this is the way you find the dot product. A vector dot b vector. Alright, and I think already I have told you how to find the magnitude. Now what is the use of this dot product? Like if this is we consider these two vectors, like this is a and this is b. See, the dot product has a use whenever we discuss the scalar product, that I'll discuss in the further lectures. But here, how it will be helpful in vectors, like if we have an angle between two vectors, that is any angle theta, so we can find that angle theta with the help of dot product. So a dot b, which I've already told you how to find, so this a vector dot b vector, that is equal to 17, which we have already found, and then it is like the magnitude of a and magnitude of b. All right. So this will be how to find the magnitude of a. The magnitude of a will be 3 square plus 2 square plus minus 4 square, and the magnitude of b will be 1 square plus 1 square plus minus 3 square in the brackets. So this would come out to be root 29, and this would come out to root 11. Now all what we have to do is we just have to frame the values here in this relation. We have to just frame the values here. So what will be these values here? The dot product is 17, the magnitude is 29 and 11. Alright, and then we can easily find this cos theta. This cos theta is the angle between the two vectors a and b. Okay, now the next topic. The next topic is the cross product. So we'll discuss this formula later on. So let us consider, first we have to First we need to know that how to calculate the cross product. So let us consider these two vectors a and b, and we have to frame them in the determinant. Okay, we have to frame them in the determinant. How to frame them? I cap, j cap and k cap is common between them, so we just make it as the first row. I'm just explaining you simply here. The exact mathematical reasoning for this is in mathematics. Fine. Now the I cap, j cap, k cap is common, so I have made that as the first row. And then we have the values like x, y, z will be the values only. In pqr will always also be the values in x, a vector and b vector. Fine. So if I am writing a cross b, now this is the important point to note here. If I am writing a cross b, I have to write the values of a first, and then I have to write the values of b. Fine. Now the next thing is to solve this. To solve this determinant in the I cap, when you have to solve this I cap, just forget about j and forget about these values which are lying under this I cap. So we just have to cross multiply this y with r and q with z. So this will be I cap multiplied by yr minus qz. Now if we have to solve this j cap, this will be negative. J cap is always negative in the determinant, like not in the determinant. While solving this determinant, the middle term we take it as negative. So this will be minus j cap, and we multiply, just neglect this and neglect this. So this will be xr and pz. And in the end, we have this k cap. So this will be like, neglect these two values here. So this will be xq minus py. Fine. So this is as simple as possible. Now let's try to consider an example here. So this is the same, like the vectors are same which I took it in the previous example. Alright, now let's try to understand this. So we have a cross b. So this will be 3, 2 and minus 4, and it will be 1, 1 and minus 3, 1, 1 and minus 3. So we have just framed these two values in the determinant, and let's solve this now. Now for this I cap, it will be 2 multiplied by minus 3, 1 multiplied by minus 4. So this will be I cap minus 6 minus of minus 4. Then it's like j cap, it would be 3 multiplied by minus 3 and 1 multiplied by minus 4. So this will be 9 minus of minus 4. And then it would be k. K will be like 3 multiplied by 1 and 1 multiplied by 2. So this will be 3 minus 2. Okay, so just add them and write this vector. So this will be minus 6 plus 4. This will be minus 2 I cap. 9. I think it was a negative 9 here, because it was 3 multiplied by minus 3, negative 9. So this will be minus 9 plus 4. That would be minus 5, and I think with the negative outside that will become plus 5j, and it will be k cap in the end, because 3 minus 2 is 1. So this is the answer. This is a cross b. So in vectors, whenever we are going to discuss the cross product and the dot product, they are two different things. They are two basic different things here. That is like a dot b is known as the cross multiplication, and sorry, a cross b here, and a dot b is the dot product. This is the scalar multiplication of vectors. So we'll discuss the physical significance of these two things in the upcoming lectures. So these are the basics, like these are the mathematical basics which we have to follow. Alright, now let us consider one problem which will help us to understand the topic better. So we have two vectors, that is like a vector and b vector, which will be given to us. So let's add them. Like this is like the simple addition and a simple subtraction. So if we just add them, a vector and b vector, this will be minus 2i plus 3j minus 4k, and this is 3i minus 4j plus 5k. Let's add them. So what we get, that will be I cap minus j cap and plus k cap. Fine. And let us subtract them now. If we are just going to subtract them, so the signs have to be changed. So let's change the sign now. This will be negative, positive and negative. So this will be minus 5 I cap, 3 plus 4 is 7, and minus 4 and minus 5 will be minus 9 k cap. Simple addition. Like it follows the same algebra which you have already learned in class 7th. Might be 6th or 7th or 8th, whatever it is. Now the next thing is the dot product, which we have just learned now. So how we are going to deal with this dot product? That will be simply multiplication of the values, the numbers, and adding them. So this will be minus 2 and 3. Then it will be 3 multiplied by minus 4. And in the end it will be minus 4 multiplied by 5. This is minus 4 and 5. So let's add them. This will be minus 6, minus 12, minus 20. That should come out to minus 38. So we have these answers here. You can follow these answers. And in the end, this is the cross product. Let's frame the determinant directly. This is I cap, j cap and k cap. So this will be like the values of a first, because we have to find a cross b. So the values of a will be minus 2, 3 and minus 4. Then it is 3, the b vector is 3, minus 4 and 5. So how to solve this? I have already explained you. This will be I cap will be 3 multiplied by 5 minus of minus 4 and minus 4. Like this would be 3 multiplied by 5 minus 4 and minus 4. Then for the j cap, it would be minus 2 multiplied by 5 and 3 multiplied by minus 4. And in the end, if you have to consider this k, so k will be minus 2 multiplied with minus 4 and 3 multiplied by 3. So this will be plus k minus 2 and minus 4 minus 3 multiplied by 3. So let's solve this now. This would be 15 minus 16. This should come out to be minus I cap. This will be like 15 minus 16 here. And then for the j cap it will be like minus 10 and plus 12. This will be minus 10 and plus 12 in this bracket here. So this would be 2 and it should come out as a negative outside because there is a negative here. Then we have in the end, this is 8 minus 9. So that will be minus 1. That's minus k cap. So here we have the answer. So this is the way you have to proceed with the basics of the vectors. Alright. Now let's go for one more important thing, which is like the rectangular components of a vector. Okay, so as I've already discussed with you, like you can consider a vector in 2D or maybe in 3D. So rectangle is generally a 2D figure. So how we are going to discuss these rectangular components? This is basically known as the components of a vector. Fine. So it's like very simple. In the class 9th, when you were introduced with the trigonometry, you were told with the cos theta and the sin theta. You can consider a right angle triangle. This is the right angle, and you can consider this angle as theta. So the side which is adjacent to the theta, that is base, in front of theta, that is perpendicular, and the slant is the hypotenuse. And whenever we are going to discuss the components, we need these things. So cos theta is always base by hypotenuse, and this is sin is perpendicular by hypotenuse. So what we can do is we can find the value of base and the perpendicular from here. The base will be h cos theta and the perpendicular will be h sin theta. And it's very simple. Like it's very simple to locate these things also. So always whenever we see a vector has two parts. One of the part is perpendicular and one of the part will be base. Fine. Now you always have to locate the perpendicular and the base. That's it. Now this vector A is having it's having two parts. One of the part is lying in the x-axis. The base is lying in the x-axis here. This is B I cap, and the perpendicular is lying in the y-axis. So that's it. So this is the first thing which you have to consider and which you have to imagine while using these vectors. Like you have to imagine these components. You have to frame these components in a vector form. So if it's like a vector is like having its base in x-axis and perpendicular in y-axis, then you can also write this same vector as a vector will be equal to a cos theta, because base is always cos theta, I cap plus a sin theta j cap. So this is the way, like this is the way we denote the vector with its components. So these are the two components of the same vector. All right. Now this vector was in the first quadrant. Now the vectors could be anywhere in all these four quadrants. Like it could be here, it could be here, here, and it could be here. So there will be 8 different cases which you have to practice. That will be like making theta here, making the theta angle with all the x's. Like you can check this. You can consider 8 different cases here. The angles could be different. I'm just taking an example. Alright. So let me tell you how to relate this now. You can also read this theory part later on. Now let's consider this example, which will help you to understand the components of the vectors better. Now you can see the angles are made with all the x's, like the different x's have the different angles, like vectors have different angles. So let's denote all the vectors as hypotenuse. H1, H2, this is H4, sorry. This is H3, it will be H5, and this is H2. Okay, so now what we have to do is we just have to make the base and the perpendicular. Rest everything will be done easily. Now for the first vector, the base is lying on the x-axis, like this is the base, and the perpendicular is lying here. So I can write the h1 vector as b I cap plus p j cap. Okay, this is the h1 vector. Fine. Now the second vector is having its base lying on the y-axis. So this is base and this is perpendicular. So this vector h2 will be equal to base as minus j cap plus perpendicular I cap. And how to write these signs? Like the signs are also important. It follows the same convention like plus plus, negative plus, the same convention of the quadrant system. This will be negative negative and this will be negative, no, positive negative. So see, I cap is positive, x is positive, y is negative. Alright, now let me go in the second quadrant here to mark this theta 3. So this will be the perpendicular and this is the base. So if I have to write this h3 vector, it will be like base lying on the minus x-axis plus perpendicular is lying in the y-axis. So this is minus plus. The convention is correct and it has to be correct. Whenever you solve this, the convention always have to be correct. And for this theta 4, when we make this theta 4 here, this is the perpendicular, this is base. So h4 vector will be equal to base lying in the y-axis plus perpendicular lying in minus x-axis. So this is the fourth vector. And let's go for the fifth one. This is P and this is B here. So the fifth vector will be B minus I cap plus P minus J cap. Okay. So these are the components, or this is the way which you have to resolve the vectors, the different vectors in all the components. But the major thing is if you just look at B and P, like the base and the perpendicular, then it's like the substitution only. Alright, now let's make the substitutions also and let's finish this problem. So this would be like, for the h1, that will be like h1 cos theta I cap and sin theta j cap. So the first is correct. So this is correct. Now let's go for the second one. This is like h2, which is like base. Cos theta is in minus j cap. Okay, the cos theta is in minus j cap and sin theta is in I cap. So sin theta is in I cap. This is also correct. Now let's verify this third one. Base is negative, cos theta will be negative and sin theta will be j cap. That should be positive. Just check it out. Cos theta is negative, sin theta is positive. That's also correct. Now the fourth one, here we have base as positive y and perpendicular is negative x. Base cos theta is j cap, correct, and sin theta is minus I cap, correct. And let's go for the last one now. So that will be h5, that will be cos h5 cos theta minus I cap and h5 sin theta minus j cap. So these are the basics which you always have to follow while considering these all vectors. Now it could be a mistake here. I have not written the angles as numbers. You can name these numbers here, but the main thing is the concept. You have to understand the concept, how to write this sine and how to write this cos using the specific directions.